Hello friends. So today we are just going to learn about the model evaluation matrix. What is the model evaluation matrix? Model evaluation matrix means whenever we create in AI any model, so we need to know how model is performed, right? Different models and different their evaluation exists. Here we are talking about the for the classification model, right? It means need to determine is it, for example, for classification model means need to determine is it value true or false, or like head and tails. What will come if we toss the coin at that time? What will come? Is it come head or tails? For example, another example we can take is spam of email. Is it the mail is spam or not spam, right? Means the value is fixed either this or this, right? So for that there are different models evaluation metrics exist. One is the accuracy, another is the precision, third one is the recall, and fourth one is the punishment, right? We will discuss here about the accuracy. What is the accuracy metric? Accuracy matrix is a very simple matrix, right? In this matrix what happens, so we need to know what exactly accurate value are there out of x. If y value is the accurate out of x, then y divided by x. For example, if you have a three three records, in three records, two are correct, then two divided by three. Yeah, if one is correct out of three, then one divided by three. For example, here we have a three scenarios. One is the exactly a mail is spam, right? And prediction is also spam. Then the true, right? This is true positive. Another is the email is not spam and prediction is also not spam. This is true negative. Means that is also not spam and actual value is also not spam. Prediction is not spam and actual value is not spam, right? And third scenario is actual value is not spam but prediction is spam. So at that time, at this scenario, third record is a correct prediction, not, but otherwise it's a incorrect prediction, right? So correct prediction divided by total prediction, incorrect prediction and correct prediction, right? So total number of record is three for here. For here you can see there is the total number of records are three. One is spam, actual value is spam, prediction is not spam. Uh, Actual value is not spam, prediction is not spam. So both are two are correct, but third one is the not spam, but prediction is spam. So correct prediction is the two, and no total prediction is three. So that is very simple. Two positive plus two negative divided by total 2 by 3, that is 66%. Now we are coming to the another point. This is the very important topic, that is the recall and precision. Recall and precision is the very important because it's a very confusing thing, right? So we will discuss about the first precision. What is the precision? Precision means precision measure how many predicted positive are actually correct. For example, if you model marks 10 email as a spam, but actually 7 are the actually spam, right? So at that scenario, what is the precision? 7 are the actually spam, but your model predicted 10. So 7 divided by 10, and that is the value is zero point 0.7. Come with some formula. Formula is precision equal to true positive divided by true positive plus false positive. Means true positive means 7 were the actual one, right? Whereas the true negative, true false positive means false positive is 3 out of the 7, 3 out of the 10, there were the 3 which are the false positive. Means they were not spam, but your model identified that they are the spam. So in precision, what will happen? True positive, which is 7, divided by true positive 7 and false positive, which is 3. So 7 plus 3 means 7 divided by 7 plus 3, which is the 10. So 7 divided by 10. Now come to the recall. Yeah, I will also discuss recall and precision uh, later on this slide as well. But let's come with the recall as well so that we can interlink each other, right? So here, what is the Recall is the output of all actual positive cases, right? Divided by true positive plus false negative. Whereas in the precision, we use the false true positive plus false positive. Whereas here, what we will do, we will add in place of false positive, it's a false negative, right? Let's come with some example as well. Recall how many are actual positive on the model detector. Out of 20 email are spam, but actual detection is the 15, right? So 15 divided by total. Now come with formula. Formula is two positive is 15, right? And divided by true positive. True positive is your 15 plus false negative. False negative means 5 email which is a spam, right? But your prediction is that these are not spam. So that is a false negative, right? So divided by 15 divided by 5, 15 plus 5. Now come with some more examples, right? In precision, always it's depend upon the quality, what the quality we are getting, right? Whereas in recall, it's a depend upon the quantity, right? Always remember that the precision is the quality, what is the quality of value or model, and recall is the quantity. Precision always prediction correctness, whereas the recall always cover the actual positiveness, right? So in precision of all the people predicted, for example, okay, we come with some example like in precision. Suppose if you have a spam detection model and model predict 100 email are spam, right? In the 100 email are spam, let's come to the question. If 100 email are spam, but actual were 80, 20 were not spam, but prediction is as a spam. So true positive is 80, whereas the false positive is 20, right? So precision will be a true positive divided by true positive plus false positive. False positive why? False positive because 20 were not spam but your prediction is spam. Right? So that is something 80 divided by 80 plus 20, that is a point 0.8. Whereas in recall, same thing we are taking, that actual spam is 120 but model is detecting 80, whereas 40 it's leaved or missed. So true positive is 80, right? And false negative is 40. So 80 divided by 80 plus 40, that is a 0.67%. So precision and recall always talk about the correctness of positive prediction. This is the precision, whereas the recall always find the all positive case, right? So whenever a model says yes, means how often it is correct. Whereas in recall, out of real yes cases, how many did we detected? This is the recall. Again, we can take an example of the precision that in a cancer detection model, precision is of all the people predicted as a cancer patient. How many actual have a cancer, right? In recall of real cancer patient, how many models successfully detected? Are you getting my point? Getting my point means exactly the model know that how many of there are the real cancer means if you have 100 people are there, 100 people all are the cancer, but she called only detected 80 of them, right? 80 divided by 100. Where is the precision? It, how? all the prediction as a cancer patient in how many actual have a cancer, right? So in medical problem, recall is often more important because it's means the patient is very dangerous. Overall, once again, I can tell you that the for precision and recall, it's very important to know about the confusion matrix. If you have a confusion matrix, then we can discuss about this, right? So here we have a F1 score. F1 score is the balance of the precision and recall, right? Formula of the F1 score is the 2 into precision plus recall divided by precision plus recall. Let's discuss about the confusion matrix. Confusion matrix is a really confusing matrix. It shows how many predictions are compared to actual result. Means actual value, that is a TP, true positive, true negative, false positive, false negative, right? And this is the actual value, true positive. You can learn like this: true positive, true negative, false negative. Predicted yes, predicted no, actual yes, actual no, right? So this is the something about the confusion matrix. Here in confusion matrix, once again I can tell you, you can remember this like this: true positive, true negative, false negative. Positive positive, negative negative, true positive and false and like this. Again I can tell you, prediction predicted means positive positive. Predicted yes means positive positive. Predicted no means negative negative, right? Actual means yes. Actual yes means is true. Actually yes true to in predicted way, then false converted true converted into false. Actual no is false, and actual no go to the predicted no, then it will be no convert into the true. So true positive, true negative, false positive, false negative, right? So this is the confusion matrix. It's very important. Many times interviewer ask you to what is the confusion matrix. So confusion matrix show how many prediction compared to the actual result, right? Cross validation improve the model reliability. What is the cross validation? Cross validation, instead of one train test, split the data into multiple times, right? K-fold cross validation. For example, first one is the 80% train and test 20%. Another is in 80% and test value is 20%. Another three is 20% and test 20%. Right? So cross mod.